Circle theorems. Let's first go over all the circle theorems. Our first circle theorem. If we have a triangle A, B, C within a circle, where one side, in this case AB, is along the diameter, see, it goes along the diameter because it goes through the center, then the opposite angle, in this case angle ACB, is 90 degrees, as shown here. Now, point C can be anywhere along the circumference. So it could be here as well. This is still 90 degrees. As long as AB is along the diameter. Our second circle theorem is that if we have a tangent to the circle, remember a tangent is a line that touches the circle at exactly one point, and we have a radius going from the center to that point, then the angle formed between the radius and the tangent is always 90 degrees. So that's 90 degrees, and this is 90 degrees. Okay, this is true for anywhere. So I could draw a tangent right here. Radius, this is 90 degrees. Okay? Now, the third circle theorem is, say we have point A, B, and we subtend that to the center of the circle, we form an angle of 2A. Now, if we subtend it to anywhere on the circumference, we form an angle A. So this angle right here is always going to be double this angle. Okay? This is also true for this, for example. This right here will also be A, aka half the angle made when we do it at the center. Now, the next circle theorem is, say we have a chord. Okay, this line right here is the chord, and then we bisect the chord 90 degrees. This side is equal to this side. This line right here, the bisector, will always run through the middle. Okay, and this is actually how we find the center of a circle. We can draw another chord, say like this, and then we repeat the process. We bisect it 90 degrees. That's 90. That's 90. This side is equal to this side. Then where the two bisectors meet, that is the center. Because both these bisectors run through the middle. So the middle could be anywhere along this and anywhere along this. And the only point where it's common is at where they intersect. Now, the next circle theorem is, if we have a quadrilateral, any quadrilateral, where all four corners, A, B, C, D, are along the circumference, then the two opposite angles, say, look at this, this is A, and this is the opposite angle, they have to add up to 180 degrees. In this case, this is A, that means this has to be 180 minus A, because A plus 180 minus A equals 180. This is also true for the opposite sides. Say we have angle B right here, we go to the opposite side. This angle is 180 minus B, because 180 minus B plus B makes 180. So the opposite angles always add up to 180. The next circle theorem is that if we have 2 points labeled here as A, labeled here as B, okay, and we subtend it to the circumference, we create an angle of A. And we subtend it to somewhere else along the circumference, say here, we also create an angle A. This is true for all across the circumference. This would be angle A, so this is also angle A right here. Same for this. This is also angle A. Okay? However, this is not angle A. This is not A. It has to be on the same side of AB. Okay? This is why. So looking back to the third circle theorem that we did, anywhere along the circumference would be half this angle, because we combine the two circle theorems together and realize that we have the same circle theorem as this over here. The next circle theorem is, say we have two tangents to the circle. This is tangent and this is tangent. And the two tangents meet at point A. Then the distance from where the tangents meet the circle, in this case this point and this point, to point A are equal. So this and this are equal in length. Okay? Now the next circle theorem is a bit complicated, so I'm going to draw the circle theorem with you. We have a circle. Then we have a tangent to the circle. Okay? And from where the tangents meet the circle, let's call that point T. Okay? And we have a line going from point T anywhere along this to anywhere along the circumference. So let's just do that, for example. Okay? Now, the angle created between the chord and the tangent, so let's label that as A. So this angle right here is the same as this angle right here. So this angle would also be labeled as A. Okay? And obviously this is true for like anywhere. So if we do this here as well, this will be angle A. So the circumference, this will be angle A as well. Now we also can look at it from the opposite perspective. If this is angle B, okay, we have our chord here, and the points where the chord hit the circumference, if we subtend it to the opposite side of the circumference, we also make angle B. Okay? I hope that makes sense. Now, obviously, I haven't explained why all of these circle theorems work, but that is going to be what we do in the next video. Okay? Right now, I'm just doing a quick run through of all the circle theorems to prepare you for like your upcoming exams. Now, let's go over some questions which utilize the circle theorems. Our first question is this. B and C are both points on the circumference of a circle which has center O. A and B and AB and AC are tangents to the circle. Angle BAC is 40 degrees as labeled here. And we have to find the size of angle BCO. Angle BCO. So let's first see what angle we're trying to work out. BCO. So if I draw a dotted line, from B to C, we are trying to find this angle, and we'll just label it as A. Okay? Now, how do we find this angle? We have a tangent, okay? And OC meets, C is the point where the radius meets the tangent, okay? And from this circle theorem, up here, we know that if a radius meets the tangent, it forms a 90 degrees. So we know that this right here is 90 degrees. Okay, so let's write down what we've just found out. Angle OCA is 90 degrees. Okay, and we have to describe what the circle theorem is. Okay, so we can write that down on the side in brackets. Okay, but I won't do that just for the purpose of understand you understand. Now, we can see that BAC is a triangle, right? We also know that it's a specific type of triangle because we know that BA is equal to CA. So that is equal to that. And we know that BA is equal to CA because of this circle theorem. If we have a common point A where two tangents meet, the point where the tangent hits the circle to point A is the same. Same thing applies here. C and B are the points where the tangent meets the circle, and A is the point where the tangents meet. So let's write this down. BA is equal to CA. Because of that, we know that triangle BAC is isosceles. Apologies for the bad handwriting. Now, let's work out what angle BCA is. We know that angles in a triangle add up to 180. Okay, so let's find what the other two angles must sum up to. 180 minus 40 is equal to 140. Okay? But we also know that angle ABC is equal to angle ACB. So, angle ACB is just equal to 140 over 2, which is the same as 70 degrees. Okay? So we know that angle ACB is now 70 degrees. Okay? Now look over here. It seems that angle A plus 70 degrees makes the right angle triangle. Okay? So angle OCB plus angle BCA equals to angle OCA. Now, let's substitute the values in that we know. We know that OCB is angle A plus BCA, angle BCA is 70 degrees, as you worked out over here. And we know that angle OCA is 90 degrees. Now we can rearrange this to get A is equal to 90 minus 70, which is 20 degrees. Okay? So 20 degrees is the answer to this question. Now, let's move on to our next example. In this question, B, C, and D are points on the circumference of a circle centered at O. AB and AD are tangents to the circle. Angle DAB is 50 degrees. Work out the size of angle BCD. And we have to give our reasons. So we're trying to work out the size of angle BCD, which is this angle right here. Okay? Now, how do we approach this? So I see two tangents right here, AB and AD. Now we can use the same circle theorem that we used before. If a tangent meets a circle, the angle between the radius at that point and the tangent is 90 degrees. So we can label this as 90. And that also applies right here. We can label this as 90. OD and OB are the radii. So I'm just going to label this as R and label this as R. Okay? Now, I realize that quadrilateral ODAB has to have angles that sum to 360. Because angles in a quadrilateral sum to 360. Okay? And we know already 3 of those angles. So we can work out what angle DOB is. An angle DOB is the same as 360 minus 90, because that's 90 and that's 90, and also minus 50. Okay? This means that angle DOB is the same as 130. Okay? Now let me label this 130. Okay. Now, we can use one of our circle theorems to work out what angle DCB is from angle DOB. And the circle theorem that we use is this one right here. If we have 2 points on the circle and we subtend it to the circumference, that angle is half the value we get when we subtend it to the center. So as labeled here, this is 2A and this is A. So back to our question. We have our 2 points, D and B in this case, and we subtend it to the center. That gets us 130 degrees. But if we subtend it to the circumference, we should get a half of 130 degrees. So let me write this down. angle DCB is equal to a half of angle DOB. So angle DCB is equal to a half of 130 degrees, and we know that this is 65 degrees. Okay, hopefully that makes sense. Remember, we are just using the circle theorems to work out the answer to our question. Okay, so let's go over another example. This example right here. Now, often when we're doing circle theorem questions like these, there are multiple ways of solving the question. Okay, and our goal is to find the most efficient way. So we're going to find the most efficient set of circle theorems to solve the answer. Now this question is a bit more complicated than the previous two. The question states that A, B, C, and D are points on the circumference of a circle centered at O, and O is right there. AC is the diameter of the circle, and AC and BD intersect at point E. Angle CAB is 25 degrees, as labelled, and angle DEC is 100 degrees. We have to work out the size of angle DAC. So let's label that DAC. We have to work out the size of this angle right here. I'll just label that as X. DAC. Okay. Now, let's see what we can use to work out the value of X. So I see a triangle ADB. So we can find the angle ADB and ABD, and do 180 minus that, and then minus the 25 to get the angle of X. However, I think there's a better way. Okay? And we can use some of our circle theorems. We have 2 points, D and C, and we subtend it to point A, and we've subtended it to point B. And we know that, based on our circle theorems, angle DAC is the same as angle DBC. So I can just label this here as X as well. Okay? Now, our goal is to find what this angle is. There are a few ways of doing this. However, the way I'm going to use is, if this angle is 100 degrees, then this angle is also 100 degrees because it's vertically opposite. Okay? Now, I see that angle DEB is a triangle. So I could work out this angle right here. So angle ABD is equal to 180 minus 25 minus 100, and this is equal to 55 degrees, I believe. Yep, 55 degrees. So I'm going to label that as 55. Now, we also know that AC is the diameter of the circle. And if we use the very first circle theorem that we've learnt, we know that if we have a triangle, in this case ACB, and one line is along the diameter, then the opposite angle has to be 90 degrees. In this case, angle B in total has to be 90 degrees. So X plus 55 is equal to 90 degrees. Okay, hopefully that makes sense. Now I can rearrange the equation to get X is equal to 90 minus 55. And that is equal to 35 degrees. Okay? So we know that angle DAC is equal to 35 degrees. Hopefully that makes sense, guys. The key here is always to work out what circle theorems we need to use in order to solve the appropriate question. Okay? And that comes with a lot of practice and thoroughly understanding all of the circle theorems and being able to spot them, which comes from a lot of practice and experience. Okay? Now, that's the end for today's video. Please don't forget to like and subscribe. Thank you very much.